sometimes we will be having unwanted data or will be present in the data set. So what we will do, we will delete the unwanted features from the data set in order to improve the network, in order to improve the performance of the neural network. So for pooling layer does the same. It reduces the spatial dimensions, then it sends the same picture or the images to the next layer, convolution layer. We have 1 to 3 pooling layer and 5 convolution layer. Max pooling is done over here in the middle layer. Max pooling reducing the spatial dimension, and at the end you can see there are 3 FCs. This FCs is called a fully connected layer. FCs is called fully connected layer, and at the end you will be having the softmax layer. I'll tell you what is the purpose of this layer. So from the starting, uh, this convolution layer for processing the pixel data, pooling layer for, that is the process of maximum pooling is to do the spatial dimension reduction, and you have a fully connected layer. See, you can see why it is called as fully connected. See, this layer is connected to this layer, and this layer is connected to this. It is and this layer is connected to this layer is connected to this. So crisscross connection is there. So it is fully connected, which means that the output of this layer will be passed as an input to this layer, and also it is passed as an input to this layer. And see, you can see the output of this layer will be passed as an input to both the upper layer and the lower layer. See, one layer's input is passed, one layer's output is passed as an input to the another layer, and finally it will be reaching to the say, layer like soft max is done. What is the purpose of doing soft max? It is mainly used in the ALEXNet architectures for just classifying. See, all the images you can imagine like this. You will be having the more number of pixel data that will be processed, and it is spatial dimension is reduced, and we are going to transform it to the another layer. Finally it reaches to the softmax layer. This softmax layer, what it does is it just classifies. Mainly the purpose of softmax layer is it is performing the classification task. Okay, so this is the overall architecture. This is the overall architecture of ALEXNet. This is a convolution layer architecture, ALEXNet architecture. So, well, moving on to the next slide, the same whatever we have discussed in the uh, architecture. It has 5 convolution layer, 3 fully connected. So, convolution layer is there. The architecture consists of convolution layer, normalization layer, fully connected layer, softmax layer, max pooling layer. Okay. Input, as I said, from one layer to another layer will be transmitting the input. We should transmit the RGB image of size 227 into 227 into 3. It is fixed. Okay. And the output will be the image which has 1,000 object categories. So softmax layer will categorize the images. You have a convolution layer. A convolution layer is a artificial neural network, as I already said, mainly used to process the pixel data. The size of this layer is also fixed 11 into 11 to capture the broader and also features like lower level features also will be captured very effectively with like edges and textures. The next layer is pooling layer. Max pooling layer reduces, as I said, mainly used to reduce the spatial dimensions of the data while retaining important features. It keeps all the necessary features. It keeps as it is, and it reduces the unwanted dimensions. There are 3 max pooling layers. ALEXNet, in the ALEXNet, we have 3 into 3 with a stride of 2. What is the use of this normalization layer? ALEXNet architecture, we have to local response normalization, LRN, local response normalization layer. Okay, mainly from the name we can say mainly it is used for normalizing the output. Okay. Then fully connected layer, as I already explained about fully connected layers or interconnected. All the layers, 3 layers. There are 3 layers, FC1, 2, FC3. All the 3 layers are interconnected. One layer's output is given as an input to the another layer. Okay. So, and these layers are highly dense layer. So, it has a 4096 neurons. The third dense layer has 1000 neurons, and finally it has 1000 classes in the image data set. So as I said, we have one unit, ReLU, rectified linear unit activation function. What is the purpose of this linear activation function? Is used in neural network, mainly in deep neural network we are using mainly for simplicity and efficiency. What it does is, it does outputs the input. Okay, the ReLU function is a linear function that outputs the input directly if it has only the positive value. Otherwise, it outputs the zero value. This is the function of ReLU. It outputs only if it has a positive value, and if it doesn't have the positive, or if it has a negative, it outputs zero. So the purpose of this pooling layer is to reduce the size and complexity of the images, and main operations like it maps 2 into 2 or 3 into 3 outputs with a maximum value. So the rest will be explained in the next session. Thank you.